Thank you very much, Callum. I will give you our usual review of what's been happening over the past few months in the sky and some pointers to what to look for in the next month or so. I normally work out from the sun and start with that, but I really haven't seen any images of the sun. People haven't been sending me any, and nobody has been sending any to the BAA website either, so really there can't have been much going on the sun. But I thought I'd show you this piece of work. This is really good. This is Mick Nichols working with a very small telescope from Sheffield, and he's just been keeping a consistent record, and he's got his own record of the sunspot mean daily frequency from 1993 to the present, and you can see that we're still in a very low period. But I like highlighting these people who are using very modest equipment. You mustn't get the impression you need these very high-resolution spectroscopes and big telescopes to do work which is of interest to the BAA. I used to prepare these kind of talks by asking the section directors what had been submitted to them, but nowadays we do it more through looking at what's been submitted to the members area on the BAA website. So if you haven't got your own account on that members area, do start one. And the amount of material we're getting now on this, and a lot of new people have joined recently, is really amazing, and it's really impressive, some of the things, and it's hard to choose what to include, in fact, because we've got so many interesting and high quality and unusual observations. So Mercury and Venus, the inner planets, well, they're invisible at the moment. They're extremely close to the sun. We had the greatest western elongation of Mercury just on the New Year's Day, and that's it was 23 degrees from the sun. It's now heading towards superior conjunction on February the 17th, and Venus is right at superior conjunction now. It was at January the 9th, so you can see on that plot it's in exactly the same place as the sun. Really, the sun is actually this little inconspicuous dot, and Venus is here, and there is Mercury, and Saturn is pretty close. So these are all too much in the twilight to be seen. This plot, by the way, is due to a piece of software on the internet by a member of ours, Dominic Ford, who's also done a lot of work on the BAA website. And this is a fantastic website, inthesky.org. This is really the best source of information on what is in the sky at the moment, in the known universe. And I've made a lot of use of his website in preparing this talk, so do have a look at it and make use of it. But we did have an observation of Mercury submitted recently from Saudi Arabia. In Saudi it gets darker more quickly. Well, the twilight is different, so it was quite fortuitous, and our member Colin Henshaw managed to capture Mercury over the roof of a shed. He said it was spotted rising over a neighbouring house, and he saw it a few times, and it was actually quite conspicuous. We've got a couple of eclipses coming up. Unfortunately, they're not visible from here. The total lunar eclipse of 31st of January is visible across a large area of Asia and into Eastern Europe. Then we have corresponding partial solar eclipse on February the 15th, and this is also from In the Sky. This is an animation. Will an animation play? Yeah, there it goes. It's that red bordered area is actually the area in which you'll see a solar eclipse. In other words, it's Antarctica and a little bit of South America. So it's not that many people will go and see this one, I think, considering it's only a partial solar eclipse. So we've just had a new moon, and here are the dates of the moon, and the January the 31st one is the lunar eclipse, and then the February the 15th one is the solar eclipse in South America. At this time of year, it's good to look at the moon between first quarter and full. That's when it's at highest up, and that's when we have the gibbous phase of the moon, which reveals a lot of the best features. Here's another Mick Nichols image. He's using very modest equipment, and this is actually taken with a camcorder. There's no telescope involved here at all. And he's captured a good libration, an unusual northern libration, where the north pole of the moon is tilted more towards us than normal, and you can see the Mare Humboldtianum, is that what, which is there. So that's nicely spotted. In the last lunation, I took some images at the gibbous moon, and here's a couple of famous features: Copernicus, taken with a 14-inch telescope, and the great craters Longomontanus, Clavius, and Maginus. We've got maybe some occultation interest this month. Here's just a couple of brightish ones that I've picked out. On January the 27th, we've got a grazing occultation of a magnitude 5.5 star in Taurus, and this tracks across southeast England, and the moon is 45 degrees altitude, and it's 81% sunlit, but it goes across South London and into Surrey and Hampshire, so a very populated area, so maybe we'll have a few observations of that. Then the brightest occultation in February is by Gamma Librae, and that's on February the 8th, and then the moon will be 45% sunlit. We've had some close encounters of the superior planets in the morning sky, some conjunctions. Here's Jupiter and Mars. This chart is for tonight, no, it's for tomorrow morning, at just before sunrise, at half an hour before sunrise. So they're close together in a bright sky, and Saturn is right down there, still in the twilight, but Jupiter is rising in a dark sky now. And we've had some nice pictures. Here's one by Mick Nichols again, of a close encounter of Jupiter and Mars, taken on the 8th of January, and here's a more close-up image taken by Damien Peach on the 4th of January. Jupiter and Mars, and Mars imaging has started, and here's another Damien Peach image. This is with the 1 meter telescope that he's using, which is in Chile. And here, despite the fact we're quite a long way from opposition, we're still about 7 months from opposition, he's captured nice images showing the Syrtis Major, the V-shaped region, or inverted V-shaped region up there, and there's also equatorial cloud bands stretching across the disk. And so this is taken with a commonly available amateur camera, one of the ASI cameras, but with a much bigger telescope than you've got. The dwarf planet number 1 Ceres used to be regarded as the largest asteroid. It's now the number 1 dwarf planet. That's at opposition very soon. That's at Cancer, and so it's nice and high in the sky, magnitude 6.9. And here's another Mick Nichols image, again taken with very modest equipment, 75mm lens, and just 5 by 6 second exposures. But people don't do this very much. You don't very often see pictures of the major asteroids. People should submit those kind of things. Here's a more difficult asteroid observation. This is by Alec Pratt and taken with Celestron 11. And the story he gives here is that this asteroid Teresia was predicted to occult to magnitude 10 star on January the 6th. And his observatory was in the predicted shadow zone. Probability of success 55%, and he got the occultation duration of 3.76 seconds. The reason people do this is so that if we got a number of observations from different stations, you get different chords across the asteroid, and we can deduce the shape of the asteroid. Here's again another Chile scope 1 meter image of Jupiter. So Jupiter is coming to opposition in May. It's very unfavorably placed from the UK. It's only going to get to about 18 degrees altitude. So really southern hemisphere observers are at a big advantage. There's the great red spot, and you see there's not much south equatorial belt. There's not much south temperate belt, and The Great Red Spot is very well separated from the South Equatorial Belt and getting smaller all the time. A question came up the other day on the BAA forum: how small a telescope can you use and detect the Great Red Spot? I can certainly see it with a 4-inch telescope, but I haven't tried smaller telescopes, so it'd be interesting if people could look and find out what the smallest telescope is that they can reliably see it with this year. Because I think because it's getting smaller but more concentrated, and the red colour is getting more concentrated, it's actually easier to see than it used to be when it was bigger. It's like the shadow transits. When you get a very dark spot, they're actually very tiny features in terms of angular diameter, but you can see them in very small telescopes because the contrast is so high. So have a look at the Great Red Spot. And Damien says that in taking that picture, that was unusual in that he had an earthquake. He didn't have an earthquake in Chelsea, he had an earthquake in Chile, and the image started shaking badly for 20 to 30 seconds, and it was a magnitude 4 earthquake, and that shows where it happened, and the telescope is somewhere around there. Haven't seen many images of Jupiter from the UK so far, but we've had a few goes, and Peter Edwards has had a go, and that's a pretty creditable attempt, and that's with a Celestron 14. So it'll be tough this year. However, a lot of interest in Jupiter at the moment because the Juno spacecraft is there. And there's a big article, there's some big articles on the BAA site from John Rogers about what's going on there. Here's a diagram of the orbit of Juno, and you see it's changing because it's moving in this vertical plane all the time, and Jupiter going round in its orbit. So whereas when it first started at Jupiter, it was going more or less along the terminator. Now it's crossing the terminator and going more onto the sunlit side. We're at a stage which they're calling Perigove 10 at the moment. And here's some amateur images where John Rogers has tried to outline some of the main features that are of interest to the Jupiter section, and we're comparing these features in amateur images with what the space probe is showing us. So some of the things he's looking at are what he's calling the STB ghost, which is a remnant of the STB, and what else is there? There's the oval BA, which is down there, the little red spot, and there's the rift in the South Equatorial Belt. And so here's some of the same features with the Juno probe. This is what he's calling the STB ghost from Juno, and this is what he's calling the split in the North Tropical Belt, the North Tropical Band. Here is some of the storms in the North Polar region, which of course we can't see from the Earth at all. I must emphasize, these aren't just images that are lifted off the NASA site. Amateur work has actually gone into these. John Rogers and other amateurs have actually been processing these images for the Juno team, and he's doing his own analysis on them. He's putting them together, he's adjusting the contrasts and the colours and so forth to bring out the features that he's trying to bring out. So this is some pro-am collaboration again. Cyclonic ovals. So that's Jupiter. Saturn's not visible at the moment and won't be visible really until much later in the spring. Neptune and Uranus are in the evening sky. Neptune is going very much down towards the twilight now. This is the evening sky about half an hour after sunset, and there's Neptune. But Uranus is still quite accessible. It's still quite high. It's still up for several hours after sunset. And in December we had quite a few observations of Uranus submitted to us. This is Martin Lewis working from St Albans with his homemade 18-inch telescope. This is showing some of the moons. This is showing the polar hood brightening of Uranus. No spots evident in this image, but we're keeping a watch out for spots. Here's a Damian Peach image, again taken with the Chile scope. It doesn't really show any more, does it? It shows that brightening, and it shows one of the bands, but again, no spots. These images are taken in infrared, and the near infrared around 700 nanometers, that's where we find the amateur cameras can get reasonable images of Uranus, and the contrast of the features is greatly enhanced. Here's another Uranus image. This is Richard Bosman in the Netherlands, who regularly contributes to us. And Neptune. Neptune, again, from Martin Lewis in St Albans with the 18-inch telescope. You can't really identify any particular features there, but spots have been seen by amateurs using this imaging technique, so we're keeping watch. We've got no significant meteor showers in the next couple of months. Here's a late quadrantid. The quadrantid ended about the 5th or 6th of January, but Dennis seems to have spotted one more recently on the 15th, and that's a fireball. That was a bright one. Comets, well, it's a bit of a sad story. The Comets really are relatively new. Comet section director has still not produced any truly grand spectacles. So he's on probation. That's all I can say. In the sky at the moment, these are the brightest ones. There's one called Haines, which is in the far north of the sky in Lacerta. It's visible all night, magnitude 10-ish, and Pan-star C6 to 2016 R2, that's in Taurus. That's very well placed in the evening sky. I actually had a look for that last night with my Celestron 11, tried to image it, but I couldn't see it, but it was poor conditions anyway. So there we are. So I couldn't spot that, but we've had quite a lot of images of that comet. This is that one. This is no, this is not. This is Haines. This is Haines, which seems to have a bit of a tail, some evidence of a tail, I would say. And this is taken by Dennis Baczynski from the north of Scotland. This one is the other way up for some reason, but this is Peter Carson, very active comet observer in the Southend area, and the tail's showing up very nicely there. This is that was January the 2nd, that image, and this is Pan-stars. And here's a Damian Peach image. This is taken with this must be a remote telescope. This is a 16-inch astrograph. I don't know where this telescope is. He says he's not in colour due to technical problems, but the tail is now looking really impressive, and that's a 13-minute exposure. Here's another Pan-stars, again Peter Carson taken by Peter Carson from Leigh-on-Sea in Essex. Some interest in a comet called 174P. It's been in outburst, and I don't know what magnitude it was before it outburst, but it's attained 14, and it's getting bigger. It's got an expanding coma, and our members have been measuring its brightness and measuring its coma size. But the total magnitude has been very consistent, whereas the coma has been expanding linearly, so that would seem to suggest that the light reflection is mainly off the dust. So it's off dust particles, and the dust particles getting further apart, it's getting bigger, but the total number of dust particles are remaining the same, so it's not getting its brightness is not changing. And this is that comet. This is 174P, and it is a very, very fuzzy, very dusty looking thing. An image from Peter Carson again. And on the variable star front, I thought I'd mention Myra, which is well placed at the moment, and it has been near maximum. Gary Poynier reported the other day on the 7th that it had got to magnitude 3.7 following one of the faintest minima on record when it had been down to about 10-ish, and it hasn't been that faint since 1930. And it's expected to start fading, but it will remain bright enough to be visible with the naked eye during February and March. Its period is 331 days, and monitoring it 3 observations a month, he reckons, is about optimal. If you do it more than that, apparently that's not good. Apparently that can introduce more bias. But you can monitor the decline of Mira, and there's the long-term light curve over the last 12 years or so. Mira means the wonderful star. It was known to the ancients, so it's one of the oldest known variable stars. And of course it's been observed by the Hubble Space Telescope, and it's got this amazing trail behind it as it goes through space, shedding shells of material. Heading further out into space, we've got members making observations of supernovae, as we've already heard tonight. Here's a supernovae discovered already this year, and David Swan in Tynemouth said it's circumpolar, and therefore he's monitoring it as often as he can, and he's making measurements with an unfiltered CMOS camera, and so he's not. This is I don't know what magnitude it is, but there's a plot from the software which measures the brightness. Here's another image from Peter Carson, and he actually imaged this supernovae, 2018 GJ, on the very day of its discovery, January the 15th. You notice how this system we've got on our website allows me to get very recent images in, and I put one in just this morning, in fact, which was submitted yesterday. David Boyd has been looking at not a supernova in a remote galaxy, but a nova in an external galaxy. This is a recurrent nova in Messier 31, the Andromeda Galaxy, and it is the most frequent recurring nova known. It has a frequency of a year. It's thought to be a massive white dwarf, and it's a good candidate to become a Type 1a supernova. Here's observations over well, these are just a few hours. This is AVSO data, and that's David Boyd's picture of it. There it is, and there's quite a story around this, which I'll read out. He had a prediction, which was that it should reach brightness sometime in late 2017, early 2018, and on New Year's Eve he was watching out, and there was just a few clear patches. He thought it was worth a try, and he started imaging, and he had a lot of wind shake. Only half his images were worth stacking, but he knew from memory where the supernova should be. He'd studied that patch of sky many times, and it wasn't blank this time. There was a distinct image at the correct coordinates, and it was mag 18.5, and there was had been no announcement that an eruption had been detected. So was he the first to spot it? He measured his images with the software, and he got an accurate magnitude estimate. He sent off the supernova. He sent off the email to the group, and within minutes, his collaborator at San Diego State University said it looks good and the detection is likely. Shortly after, he got confirmation from an observer in the Czech Republic, and an astronomical telegram was produced announcing the discovery. Then the SWIFT satellite was triggered to observe the nova, so this is considered an important thing. The 2-meter Liverpool telescope was quickly put into action on La Palma to take the spectrum, showing emission lines, and David continued taking the images into New Year's Day, and this was he could do other things. This was his remote system. And the nova was still brightening, and later it was discovered that Chinese astronomers had already imaged it on December the 31st, but they hadn't looked at their images, so they had the pre-discovery images, and they showed the nova fainter, but they hadn't reported it, so they had missed the opportunity. And it's now declining. It's exhibiting short-term variability. So this is a tremendous piece of work. And it shows you what dedication does, and we have so many people in the BAA doing these things. Well, how to top that? Well, this was pointed out to me by Jeremy Shears, an observation that he noticed on the Stargazers Lounge internet forum. And this is not, I don't know if Dennis O'Keefe, who works in Ireland, is one of our members, but he's using a Celestron 11, and he's been observing an exoplanet transit and got excellent data on that. And on Stargazers Lounge there's actually a link to a YouTube video which shows his telescope tracking. It's a video taken with a fisheye lens on another camera. It shows his telescope tracking across the sky, and it shows in corresponding time this graph actually building up where the telescope was pointing and how the sky was looking as this graph was building up. And it's a really nice piece of work. I couldn't I thought it was too risky to try and incorporate another video in this presentation. It was asking for trouble, but that's really worth the look. And here's another I've never heard of this before. Another of our very active observers. This is Tim Haines, who I associate with occultation work, and he does a lot of work on lunar occultations and minor planet occultations. I didn't know he was a deep sky observer as well, but he's taken an image of this area. Well, you'll immediately say this is an image of the famous Rosette Nebula, just to the left of Orion, and indeed it is, and there is the Rosette, and there is the Cone Nebula at the top, but there's something else in there. And Tim found a paper that said, or speculated, that in the area north of the Rosette Nebula there's another supernova remnant. The Rosette is something to do with a supernova or nova as well, because it's the result of stellar winds blowing out this shell. But there's another remnant here, much bigger remnant out there, which you'd need a really wide field system to spot. And he took this image with a 200mm lens. So it's not a camera, it's a relatively long telephoto lens, and quite a common camera. Well, so it's astronomically modified camera to make it sensitive to the hydrogen alpha light, a Canon 60DA camera. And it's not that long in exposure, it's only 4 2-minute exposures stacked, and here it is, a remarkably deep image, and he confirmed this thing, which has apparently only ever been reported once in the literature in one paper from quite a few years ago. This shell of gas, this supernova remnant between the Rosette and Cone Nebula, and that was just the other night, wasn't it? That was just the night before last that he took that, so on the 19th, so you heard it here first. And we're heading into the spring. We'll shortly be heading into the spring, the galaxy season, where we're able to look at the great galaxy clusters in Virgo and Coma and so forth. And here's a nice image. But on a very small scale, showing a famous galaxy, the Fireworks Galaxy, in its natural habitat. And this is quite nice to see these wide-scale images of some of these galaxies, making them really small. And this is again a 200mm lens and a Canon DSLR camera. And this is from Graham Winstanley in Lincolnshire. And that's a lot of exposure, actually. That's 46 2-minute exposures. And I managed to get this one in. This is my observation from the night before last. Was very clear. and I was able to image this quite a famous galaxy. This is NGC 2903, which is in Leo. It's just near a star called Algebra, which is it means the glance in Greek. It was visualized as being the eye of the lion, or the glance of the lion, and I think that's rather a nice name. And this is a lovely barred spiral galaxy, and that was taken with my 14-inch telescope, and I was helped or hindered by a whole team of stray cats which have recently invaded my observatory. So if anybody would like a cat, please see me afterwards. We're feeding these blinking things. I found them after I came back from the Eclipse in America. They seem to have been born there, and we really don't know what to do with them.
Well, I could make some suggestions, but probably they're not good suggestions.
But they try and help, but their knowledge of observational astronomy is sadly lacking. It really extends mainly to chewing the carpet tiles.
They actually live inside.
No, they live underneath it. And then they come in when I open it up. I'll mention some public observing opportunities in the London area. My society, West of London Astronomical Society, is holding some public observing sessions towards the end of February, 23rd, 24th, 25th, at a place called Ruislip Lido. So if it's clear and you're in the area, come along down, and that's the website, which will say whether it's on or off or not. And we've got quite a nice site there. It's still within London, but it's a lot darker than it is in central London. But people do observe from central London. The Baker Street irregular astronomers regularly observe from the hub in Regent's Park, and they may well be having a meeting on Wednesday, January the 24th, but you can check their website about that, and that's a picture of the hub. It's like this pavilion, and you can get teas and coffees there, so you don't get too cold. And this is mainly advertised through Facebook, and one recent meeting a couple of months ago, I went down there thinking it won't be much good, there won't be much doing there. In fact, it was I think it was after the November BAA meeting, and it was partly cloudy, and there were hundreds of people there. It was amazing, they've got lots of very young people and people who don't know anything about astronomy, and somebody brings a 14-inch telescope along there, which is like a series of oil drums bolted together. So it's a fun thing. And with that, I'll wish you clear skies, and I'm doing the next Skynotes as well. I think it's beginning of March, so we'll see you then.